Good day, everyone. I am King Jacob and Javier from 3BSMA1, and I'm going to report the topic on vibration under general forcing conditions. The general forcing conditions may be periodic, harmonic, or non-periodic. Periodic vibration refers to the repetitive back and forth movement of an object or system, characterized by a consistent time interval or period between successive cycles, while non-periodic vibration include forces such as a suddenly applied constant force, called a step force, a linearly increasing force, called a ramp force, and an exponentially varying force. For the examples of the general forcing functions, the motion imparted by a cam to a follower, the vibration felt by an instrument when its package is dropped from a height, the force applied to the foundation of a forging press, the motion of the automobile when it hits the pothole, and the ground vibration of a building frame during an earthquake. For the definition of terms, first, the vibration is the back and forth movement of an object or system centered around a fixed point. General forcing condition describes situation where external forces impact a vibrating system without following a regular or predictable pattern. Frequency, the count of full cycle or oscillation that a vibrating object or system completes in a specific time period. Amplitude is the maximum extent to which a vibrating object or system deviates from its resisting position. And lastly, resonance, when the frequency of external force align with the natural frequency of a vibrating system, causing a substantial amplification in its amplitude. The response of a system subjected to non-periodic force is commonly obtained using: first method is the convolution integral method, second is the Laplace transform method, and the third is numerical method. The first two methods are analytical ones, in which response or solution is expressed in a way that helps in studying the behavior of system under the applied force with respect to the various parameters in designing the system. The third method, on the other hand, can be used to find the response of a system under arbitrary force for which an analytical solution is difficult or impossible to find. However, the solution is found is applicable only for the particular set of parameter values used in finding the solution. This makes it difficult to study the behavior of the system when the parameters are varied. For the response under a general periodic force, when the external force Ft is periodic with the period, it can be expanded in a Fourier series. The response of system under general periodic forces is considered in this section for, for both first and second order system. First order system are those for which the equation of motion as the first order differential equation. Similarly, the second order system are those for which the equation of motion is a second order differential equation. For the problem solving on vibration under general forcing condition, in the vibration testing of a structure, an impact hammer with a load cell to measure the impact force is used to cause excitation. Assuming M is equals to 5 kilograms, K is equals to 2000 Newton per meter, C is equals to 10 Newton second per meter, and F equals to 20 Newton seconds. Find the response of the system. For the solution, Wn is equals to the square root of K over M is equal to the square root of the K, which is the 2000 Newton per meter, over the mass of 5 kilograms. This gives us the value of 20 radians per second. And solving for the stiffness is equal to C over CC is equal to C over 2 square root of Km is equals to 10 over 2 square root of 2000 times 5 gives us the value of 0.05. Uh, then substituting this value to get the response, the WD is equals to the square root of 1 minus the stiffness squared Wn will give us the value of 19.975 radians per second. Thank you, and that's all the presentation, my report.